Welcome back. Now that we've got the basics of compound interest sort of sorted out, we're going to have a look at our first formula. And unlike with simple interest, where we started with just calculating interest, we're going to dive right in to working with the maturity value, or as it's more commonly called with compound interest, the future value. The basic formula for calculating future values in compound interest is this. Future value is present value multiplied by 1 plus I to the power of n. If we were to deposit $10,000 into an account earning 7% compounded annually, or J1 equals 7%, how much would we have after 10 years? Let's have a look, and like always, I'm going to start by writing things down. So the $10,000, that's what I started with, so that's my present value. That's going to go into an account earning J1 is equal to 0.07. Now, I'm going to work out I right away here, and that's 0.07 divided by 1, or just 0.07. It's divided by 1 because I'm compounding once a year. It's just a J1, so it's a very easy one to deal with. And now we've got N, also pretty easy to deal with. We're in there for 10 years with our investment, compounding once per year, so we'll have 10 periods overall. And we want to find what we're going to have in the future. So it's a future value question, which is kind of nice because that's the only formula we have at this point. So let's have a look. The future value, present value times 1 plus I to the power of n, which in this case is 10,000 times 1.07 to the power of 10. If we work all that out in our calculators, we get $19,671.51. So after 10 years, our money will nearly have doubled. It'll have gone from $10,000 up to $19,671. Let's give you a chance to try one out. Julian borrowed $3,500 at a rate of 6%, compounded monthly this time. It's going to be a little more thinking there involved for you. How much will he have to repay when the loan comes due in 4 years? Remember, we're working with little I for our rate, and with n, we're working in compounding periods, not necessarily years. So when you're laying out your basics, make sure you take that into account. Go ahead and press pause, give it a try, and when you're ready, come on back and I'll go through it with you. All right, well, we've got a present value of $3,500 at a rate of 6% compounded monthly. So that's a J12. That means little I is going to be 0.06 divided by 12, or 0.005. I hope you got that part of it. And then to match, we have to do little n in monthly units as well. Well, we've got 4 years. There's 12 compounding periods per year. So we've got 48 compounding periods, or 48 months. And again, this time we want to find the future value. Go ahead and write down our formula. Present value times 1 plus I to the power of n, which in this case is 3,500, times 1.005 to the power of 48. And I hope you got this one working through okay on your calculator. If you did, you got $4,446.71. So your $3,500 turned into $4,446. What do we do if the rate changes in the middle of a calculation? Well, we've got a fairly simple way to deal with that. In this case, let's look at an example. Sally deposited $500 into an account, earned 6% compounded semi-annually for a little while, first 2 years, but then the rate switched to 8% compounded quarterly, so a different rate and a different compounding frequency. Well, to deal with these, we can work out the question sort of in 2 pieces. Let's have a look at a timeline and see what we mean. So for this one, she deposited $500 at the beginning, and for the first 2 years we had one rate, and then we want the answer out at the 5-year mark, so I'll go ahead and put 5 on the end of my timeline there. Now, to do this one, we're going to break it into two parts. For this first part of the question here, that's where we have the J2 is equal to 6% in effect, isn't it? Well, in that case, then I is going to be 0.03. And if I'm compounding twice a year for 2 years, N would be equal to 4. Then I'm just going to take whatever the answer to that is, and I'm going to keep going until I get to the very end. And so for that portion of the timeline, we've got our J4 is equal to 8%, which means I is equal to 0.02. And now let's see if we can work out N. 2 years up to 5 years, that's 3 years, and I'm compounding 4 times a year, so I'll get 12 compounding periods for that one. So basically, when I do the first portion here in red, I'll have an answer. And if I take the answer and keep going, then I've kept the compounding alive, haven't I? I've kept it going all the way through. So let's see how that looks. If I write it out, my final answer will be 500 carried forward at 1.03 to the power of 4. And then whatever that is, I'm going to keep going at my new rate for another 12 periods. You can do that all in one step in your calculator. A lot of people might like to break it down though and enter it sort of piece by piece. If we do that, let's just do the red part here, $562 and about 75 cents. I'll keep all the decimals in my calculator though. And then I'm going to carry that forward 12 periods, and that's going to give me a final answer of $713.71. That's how we can deal with the situation where the rate changes along the way. Now, some people at this point say, well, wait a minute, how come you didn't have plus in there? You multiplied things. Well, remember, it's not two different amounts like we've had in timelines in the past. It's just the same amount moving forward, turning into something else, and then we're going to carry it forward again. So that's why things are multiplied together. Let's give you a chance to try one out. Tim borrowed $3,500 4 years ago, and interest accrued at 7.2% compounded monthly for the first 2 years, and then it switched to 8% semi-annually after that. How much will he owe at the end of the 4 years? Go ahead and hit pause, give it a try, and when you're ready, come on back, and I'll work through it with you. All right, let's have a look. I'm going to draw a little timeline first here. He borrowed $3,500. Now that was 4 years ago. You could either go, -4 on the timeline, -2 and 0, or if you prefer, not to deal with negatives, you could just say, oh, let's make that the 0 point. Then the rate was in effect for 2 years, and then another 2 years to take us all the way out to today, which is actually the 4-year mark based on the original loan. I don't really mind how you label your times as long as they make sense. And so I'll put the $3,500 there, and it's going to earn interest at a rate of J12 is equal to 7.2% for the first little while. Well, that gives me a little I of 0.006 and an N of 24 because I've got 2 years compounding monthly. And then we switch the rate to J2 is equal to 0.08 for the remaining time. I think there's a little I of 0.04. And now this time period is another 2 years going twice a year, so N will be 4. That'll take us out to the very end so we can see what we've got at that point. So let's start by taking that $3,500 forward. 3,500 carried forward at 1.006 to the power of 24. And then once I get there, I'm going to take that amount forward again at 1.04 to the power of 4. If you want to just do it all as one long calculation, that's fine. If you prefer to break it down though and write out the beginning amount, that's fine. $4,040.36 roughly. Again, best to keep all the decimals in your calculator. No need to round at this point. And then that's going to get carried forward at our second rate in a second step. And if we do all of that, I hope you came up with $4,726.64. So there we go. When we want to break it into two parts, it's just that easy. So like I said before, take your time when you're working with these questions. Draw a timeline if necessary. Write down all the information at least, and think about, okay, little I and small n. I want to make sure they're in consistent units. Just sort of double check that you're doing that correctly. And then use all the decimals during calculations. Only round when you get to your final answer. You'll see sometimes I may only write 2 decimals part way along, but I've kept them all on my calculator. And that's the key. We want to keep them all during calculations, round when we get to the end. And that'll give you the most accurate answer and the best answer. Good luck working with these. We'll see you soon.